Hi, this is Margo. This is Sunday, July 15th, 2018, and I'm going to do a ClimateCast update for this week. It's been a little over a week since I did my last one, and I haven't done a ClimateCast update since I did the video with the hole in the Arctic sea ice, and I know people are curious as to what has happened and transpired since then. And so even though we're looking at methane, which is one of my favorite topics, let's look at quickly the Arctic sea ice and what has happened. And I got different responses on what that was. Some people thought it was a glitch in the system. Some people thought that it was missing data. Some people thought it might have been a methane hydrate coming up. Someone said it could be the opening to the inner Earth. I'm open to all possibilities here. And this was this picture is from climatereanalyzer.org from Saturday, July 7th, 2018. I did a whole video on it. Now, I downloaded the pictures from every day, and we're going to do a slideshow, and I'll show you what happened this week. And I'm going to start doing that from now on so that we can see. And some people don't think this is a good website to really see sea ice, but you know, I can't look at 10 or 15 different websites. It's just too much. So if we zoom in on this picture and look at this edge, I just wanted to get a chance for everyone to look at it a little closer. Yes, it is in a rectangular shape, but these are not straight lines, as you can see. And you can see like some blurry stuff coming in there. So, you know, I don't know if it was missing data or if it was a glitch, or if the sea ice like opened up and then it closed back. I know that the Arctic has had a cyclone. They had a cyclone recently and high winds and rain and warmer temperatures, and so that's chewing up the sea ice, is chewing it up very quickly. So I wanted everyone to see a closer shot there to see that those are not straight edges. So usually when there's a lack of data, it's straight edges from what I've seen. And okay, so that was from the 7th. Now here's the picture the next day, July the 8th, and you can see that the hole is not there, but there is a hole appearing above Canada, just north of Canada. And so let's zoom in on that. And you can see again, it's irregular edges. So, you know, it could have been a hole that opened up and closed back up here. I mean, I don't know. We can also see that there's a real thinning over here on the northeast part of Greenland. So let's watch that as I take you through this slideshow. And here's July 9th, Monday. And we can see the hole above Canada has closed back up. There's no hole up here. And this thinning is getting more above Greenland. And you can see the diminishing ice day by day. You can really see it. And when we go a week at a time, it's hard to remember what it was like a week ago. So this is why I'm going to do these slideshows as part of my report every week. Here's July 10th. Here's July 11th. Now you could see a noticeable decrease. Let's go back to July 10th. And now look at 11th. And it looks like this darker area is growing. And of course the darker is the sea ice concentration going down. As it gets darker, it's going down. It shows that it's melting. And here's the 12th. We can see this hole getting darker here above Greenland. Here's the 13th. And now we have a hole developing up here just below Siberia there. And you can see that you can see the ice retreating here on the East Siberian ice shelf, and definitely retreating all around Novaya Zemlya and the coast there. And when we go to Climate Reanalyzer today, you'll see that the sea surface temperatures in these areas are quite elevated from what they should be this time of year. Here's Saturday, July 14th. You can see a dramatic decrease again. It's much darker, so it means that this is melting, and so it's getting much thinner on the edges. And then here's from the 15th today. You can almost see just dark blue through the ice here. You can almost see it in right here, and we've still got this hole over here. Now, I did get something interesting, and I don't know if anyone saw this, but if anyone wants to see what an ice-free Arctic, what a picture of it would look like, this is the other side of the globe, and this was Monday, July 9th from Climate Reanalyzer. I'm sure this was a glitch. I'm sure this was a mistake. I don't know how, but I just have a knack for finding these things, and there's no sea ice up here. So that's what it would look like with zero sea ice. That's what it would look like. If anyone's heard of this mistake happening on Climate Reanalyzer before, let me know. I would be definitely interested. So if you want to see that slideshow again, we can, okay, so this was last Saturday the 7th, a week ago, and we're just going to go through the slideshow, and you can see the changes from day to day. And it's really thinning out all coming up from Alaska. This is a whole patch where there's warm water coming in from the Pacific, and then we've got a lot of methane coming up out of the permafrost of Alaska. I mean, it's really warming the area up here a lot, and I have a very good blog post to share with everyone today too. And there's another thing I want to show everyone. This is from the National Snow and Ice, the NS, I forget the actual name of the website, where they show the sea ice concentration. I've got it up here. It's this one, Arctic Sea Ice News. It's this website, National Snow and Ice Data Center. Okay, what we're looking at is from July 12th. This is sea ice concentration. I'm going to get it bigger. And one of my subscribers emailed me and said that day and asked if I had seen the dimples actually in the Antarctic, but they're in the Arctic too, and it's these holes that are showing up. Now, and this is, I guess this is a natural hole where the North Pole is. I mean, it's not a hole in the ice, it's just a marker. But now remember in the video before that, my last climate cast video, where I talked about the sea ice concentration, and I talked about this website and read the article that they had posted saying that they were going to be testing their satellites between July the 9th and July the 12th, and so there may be incomplete data during those times. So this was July 12th, so I'm thinking that's what that was from. But we can see the concentration. It's getting bluer, which means there's much less sea ice. And when it goes to the dark blue, that's at 15%, because they consider 15% concentration to be no sea ice. So here is the extent, and you can see those white things, the white holes. Let's go in a little bit. Now this is, I think this is pretty obvious. It's missing data, and it's here too. And then here's the Antarctic, or the South Pole, and it's showing up. Let's zoom in a little bit. But we can also see the sea ice concentration is just, it's not much. It's not as solid as it should be. See, here are the holes, here are the dimples that the person who emailed me said to look at, and up here. So, and here's the sea ice extent in the Antarctic. An extent is totally different from concentration. And you can have ice like forming on the water, but it might not be very thick. And so when it goes out like that, that increases the area of extent, but the concentration is what you really want to measure, because that ultimately defines like how much sea ice there really is. So while we're here on their website, we'll look at the pictures from yesterday. They're a day late, so that we can see how things might have changed since the 12th. And you can see the dimples there. So they still have, it looks like, some missing data. And here's sea ice extent, concentration, and it's very thin. It's very, very thin. And here's their graph. Sea ice extent compared to all the different years. We're still pretty low. We're very low. Here's the South Pole, and you can see the little holes. I personally don't think that that's holes in the sea ice. I think that's missing data. And here's the concentration for yesterday, the 14th. You can see it's very much darker blue over here. I know that they've been having a lot warmer air over this West Antarctic recently. And down here, off of, this is the Ross Sea, and down here off of this little edge here is where that active volcano Erebus is, and it's emitting sulfur dioxide. So there's that. So we'll shut that website down. We don't need that anymore. But before we go to CAMS, I want to share this blog post from Sam Carana. This is his latest blog post from Friday, July 13th. If people are not following him, I recommend they do follow him. And his blog site is called arctic-news.blogspot.com. And no one really knows who Sam Carana is. It is believed that it is a group of scientists who have come together to collaborate and be able to release information about the changing weather and abrupt climate change and everything in a safe manner for them in an anonymous way. That's what Guy McPherson thinks, or McPherson. So that's what Guy thinks, and he doesn't think that Sam is an individual, but Sam does have a Facebook page and does have the group Arctic News group in on Facebook. So join his group on Facebook and you'll get all the latest up there about what's going on in the Arctic, and also keep up with this blog post because his information is scientific. And this blog post is entitled Disappearance of Arctic Sea Ice. And I'm not going to read the whole thing, but I'm just going to hit the highlights. And so the first thing he has, and the thing I like about his blog posts are he's got lots of images, lots of graphs, lots of pictures, moving things, so that you really understand, you really get the picture of what's going on. And he says the image on the right shows sea ice temperatures on July 6th for the years 2014 to 2018 at a location near Svalbard, with an exponential trend added based on the data. Now Svalbard, in case you don't remember, Svalbard is, well, you can't see it because of all the methane, is right up here. It's up here on the Arctic Circle, and that's where the seed vault is. It's an island. It's part of Norway. So for the last 4 years, for July 6th, he's got the temperatures for the sea surface. Now this is important because if it's too warm, it's going to be melting that sea ice even faster. So in 2014, on July 6th, the sea surface temperature was minus 0.8 degrees centigrade, or 30.6 degrees Fahrenheit. And we're starting here on the graph right here. All right. In 2015, the sea surface temperature was 6.2 degrees centigrade or Celsius, or 43.2 degrees Fahrenheit. So it was like almost a 13-degree rise in Fahrenheit. So there's 2015 where it went up a little bit. In 2016, the temperature was 8.3 degrees Celsius or 47 degrees Fahrenheit. So there we are in 2016. And then in 2017, it took a big jump to 14.4 degrees Celsius or 57.9 Fahrenheit. So it jumped over 10 degrees Fahrenheit. And that's in 2017. You see how it started like really going up there. And then in 2018, this is so far, we're only halfway through the year, but it's still from July 6th. So the sea surface temperature was 16.6 degrees Celsius or 61.9 degrees Fahrenheit. So it increased a little over 2 degrees Celsius, and we're right here but according to his graph, he figures in exponential stuff, so he figures in other things besides just temperature and things. So he estimates, well, let's click on this and it gets bigger. So he estimates that in 2019 it will be up to 25 degrees Celsius. So he is estimating not quite a 10-degree increase Celsius between now and next year. So that's pretty disturbing. So if we don't get the blue ocean event this year, we will definitely next year if we're still here. And then he has pictures of how the sea ice has declined over the years, and you can just go through these. And okay, and this one shows, the image on the right shows the sea surface temperature on July 14th, 2018. So that was yesterday at that same location, and it was as warm as 17.1 degrees Celsius or 62.7 degrees Fahrenheit near Svalbard. There, at that green dot. And here's Svalbard, that island area. And his explanation says this compares to 5C or 40.9 degrees Fahrenheit in 1981 to 2011 at that location. So that's how much it's been increasing. And then this graph shows, the image below shows the Arctic sea ice volume, and that's the same as concentration, on July the 10th, 2018 was at a record low for the time of year. So we don't have more ice, we have a record low. And it's the black line. Well, we can blow this up. Here's 2018 is the black line. July 10th, it's right here. Wait, it's here. So we're at the record low for Arctic sea ice volume for this time of year. And then you can see the other years according to their color. Now, this next one is really freaky. This little moving thing, and he says the animation on the right shows a fall in volume or concentration of some 1 meter over most of the sea ice over the period from June the 21st through July the 12th, 2018, with a further 8 days of forecasts added. So we've lost a meter, a volume of a meter, just from the 21st through the 12th, so less than a month. And the animation illustrates the huge amount of melting taking place from underneath due to an inflow of heat from the Atlantic Ocean and the Pacific Ocean, and from warm water from rivers that end in the Arctic Ocean. Meanwhile, sea ice extent doesn't fall very much at all. And he says, so when only looking at sea ice extent, the dramatic fall in sea ice volume may be overlooked. So what he's saying is the water is so warm coming in from the Atlantic and the Pacific and from all the streams and stuff that are running in, that it's warming the water underneath and making the ice melt from underneath. So let's look at that close up. So you've got, these are the dates running up here. This is thickness in meters. And it's running here. And then it goes in, it starts on starts on the 21st and runs through a forecast period of the 20th. And you can see that the white is zero sea ice, which you can see how much it's retreated just since the 21st or 22nd or whenever it started. It's incredible to see the thinning just in that short amount of time, and see the blue, the purple is thin, like this purple is 0.5, and then when it goes to blue, that's 1 meter. So you can see that by the end of the forecast period, it's almost all either white, purple, or blue. But and that's only through July 20th. So there's that. And then he says, complete disappearance of Arctic sea ice in September 2018 is within the margins of a trend based on yearly average minimum volume as illustrated by the image on the right. Latent heat can make such disappearance come abruptly and for people who only look at changes in extent, rather unexpectedly. Latent heat is energy associated with a phase change, such as the energy absorbed by solid ice when it changes into water or melting. During a phase change, the temperature remains constant. Guy McPherson talks about this. Sea ice acts as a buffer that absorbs heat while keeping the temperature at 0 degrees Celsius. As long as there is sea ice in the water, this sea ice will keep absorbing heat, so the temperature doesn't rise at the sea surface. The amount of energy absorbed by melting ice is as much as it takes to heat an equivalent mass of water from 0 to 80 degrees Celsius. So here's his chart. Starting back in 1975 and showing the sea ice levels. And this is 1,000 squared, can't read that, 1,000 cubic kilometers is how it's being measured. And see, here we are, there's 2015, and each line is another year, 16, 17, and here we are on 18. Here's the line where we're headed. So it's not looking good. And then he goes into the scientific explanation of the ice melting and the latent heat infusion and how it all becomes water and all that stuff. And he says that oceans take up over 90% of global warming, as illustrated by the image below. Ocean currents make that huge amounts of this heat keep entering the Arctic Ocean from the Pacific and the Atlantic Oceans. So, let's look at this chart. So you can see back from 1960 it was going up and then came down a little, and then it's been steadily rising. This is the global ocean heat content. So here's and it's measured by 10 to the 22nd joules. And then here's our red line with it going up. Here's, okay, so it ends at 2020, and here we are at 2018. It's at 25, and it started out at almost minus 10. We're at 25. Global ocean heat content. And he says, once the sea ice is gone, further ocean heat must go elsewhere, i.e. it will typically raise the temperature of the water. The atmosphere will also warm up faster. More evaporation will also occur once the sea ice is gone, which will cool the sea surface and warm up the atmosphere, technically known as latent heat or vaporization. As temperatures in the Arctic are rising faster than at the equator, the jet stream will change, making it easier for warm air to enter the Arctic. More clouds will form over the Arctic, which will reflect more sunlight into space, but which will also make that less outward IR radiation, infrared radiation, can escape into space over the Arctic with a net warming effect. Now this is a scary chart. Look at that. That goes way, way up. This is all this year. So, meanwhile, El Niño's getting stronger, as illustrated by the above image on the right. A warmer Arctic comes with stronger heat waves, forest fires, and associated emissions, and rapid warming of water in rivers that end in the Arctic Ocean, all of which will further warm up the Arctic Ocean. Forest fires have already been burning strongly in Siberia over the past few months, and methane recently reached levels as high as 2,817 parts per million on July the 8th, 2018. I wonder if he meant parts per billion. I mean, not to doubt Sam Carana, but normally it's parts per billion. Anyway, one huge danger is that as the buffer disappears that until now has consumed huge amounts of ocean heat and the Arctic Ocean keeps warming, further heat will reach methane hydrates at the seafloor of the Arctic Ocean, causing them to get destabilized and release methane. And here's a really good graphic of that. Like, here's your methane hydrates stored up, like we've been talking about, that are 1 million years old. Then your ocean starts heating up, and then the methane starts bubbling up. And then after 2012, the sea ice got thin. Here's how thick it was compared to before 2012. And so the buffer is gone. And that's what they're worried about. Methane is coming up out of the Arctic. It's coming up out of all the oceans. Additionally, disappearance of the sea ice will come with albedo changes that mean that a lot more sunlight will be absorbed instead of getting reflected back into space as occurred previously. And so that'll heat up the water more. So you got a self-reinforcing feedback loop. Similar albedo changes are likely to take place over land in the Arctic soon thereafter. Adding up all warming elements associated with disappearance of the sea ice can result in an additional global warming of several degrees Celsius. Several degrees. And he says the situation is dire. Yeah, we'd say that. And calls for comprehensive and effective action as described in the climate plan that he has. And, you know, and here are all the contributors. So, this whole group of contributors is probably Sam Carana. And there's Sam Carana. There's Guy McPherson. So that whole group they're probably all part of Sam Carana, because they're all contributors to this blog. Contributors. I mean, they write, and so, well, maybe it's not all of them. I mean, I don't know. Nobody knows, because nobody's saying. So I'll leave the link below to this website in case anyone has not seen this before. And now let me get a drink of water and we'll go to cams. Hold on. Okay. Now we're going to start with methane. This is the Copernicus Atmosphere Monitoring Service website. This is out of the EU. I show this all the time. In my first methane video, I think on April 28th of this year, I show an explanation of how you can use cams, what it all means. So this is freely available to anyone who wants to look at this. The only data they have is from July the 10th, which was last Tuesday. They don't have any other days loaded. You know, they're up to date on all these other greenhouse gases, but they're always lagging on methane. So if the methane bomb goes off, we may, it won't show up on cams till 5 days later. So that's the way it is. But we can still use it as a tool and to see where we're at. Now this is July the 10th, and we're looking from the North Pole down. This is the United States and Canada. Here's Greenland. Here's Alaska. Here is England. Here is Europe, Spain. Here's Norway, Sweden, and Finland. They're covered up in methane. All of this Europe and these areas. Here's Russia. Here's Siberia, and then here's northern part of India and Turkey and Pakistan, and then China and East Asia and all that. So let's run this movie. And this is, it's not going away. It's just not going away. And we're in the hot time of year, and we've got wildfires burning and permafrost melting and sea ice melting and all that. So, and by the way, while this is loading, I would like to thank everyone who participated in our live talk show on Thursday, Campfire Chats with Margo. I really thoroughly enjoyed it. I really enjoyed meeting the people that came and getting to know you and hearing your voice. And I'd like to give a huge shout out to Sandy Schoelles and to Robin Westenra. They both are doing a huge effort to support me and promote me, and I really appreciate it. And they are well known in the climate change and environmental community. And Sandy Schoelles runs the Environmental Coffee House. She has a YouTube channel, a Facebook group, and Robin Westenra has a wonderful blog, and I'll leave the links below to their stuff. And Robin's blog is See More Rocks. See More Rocks. And one of these days I'm going to have to ask him how he came up with that name. So I loved the show, and I got it uploaded last night, and I'm glad everybody is enjoying the archived version, and you know, I liked it because we were able to get into some areas that people don't normally talk about. And we talked about our feelings and talked about how we first